mainly because of the ACT. So, have a nice day tomorrow. In here anyways, because you'll all be back in here by then. Now, looking at this here, 351, the square root of a negative number property. Now this here, it seems like this property has a lot to say, but it actually doesn't have a whole lot to say at all. Because if r is a positive real number, r is any real number, and we take the square root of negative r, well, this negative is going to come out as I. And then we would simplify whatever r is. Here we're just leaving it because we don't technically know what r is. It could be a perfect square, it couldn't. But we get I square root of r. By the first property, it follows if I take that I square root of r and square it, well, the I goes back to being -1. The square root and square cancel, just telling us we get back to negative r. If I take the square root of negative r, we get I squared of r. If I square it, I get back to negative r. We can go from one to the other. It goes back and forth. That's really all this is saying. Or, better yet, should have done this earlier. If we take the square root of -5, it's I squared of 5. That's all the first sentence is saying. I just picked -5 out of the blue. And if I square I squared of 5, we get back to -5. That's all those two sentences are saying. Like I say, that seems like there was a lot more to that than just that. So, what we're going to be looking at first is solving quadratics. If you didn't get that down, it's not that big a deal. Solving these quadratics, because up to this point, we've solved quadratics by factoring, graphing, in the square root method. And if we look at this first one here, x squared plus 4, I'm going to grab the graphing calculator and say x squared plus 4. Because when we graph, we're looking for where the graph crosses the x-axis. Yes? Does it cross the x-axis? No. And when we did this earlier in this chapter, we just said this is no real solutions. It has solutions, they're just not real. This is where our I comes into play. We can still solve this. We can't solve it by factoring. I mean, we could, but to be able to factor it, we really need to know the solutions. You kind of have to work backwards. But the square root method works because there is no middle term. There's no x to the first power. Square root method, we need to get the x squared, our square term by itself. And to do that, we're going to subtract 4 from both sides, telling us x squared is equal to -4. And the last one we did like this is where we got stuck. Is our next step in completing the square is to take the square root of both sides, and the square root and the square would cancel. And when we tried taking the square root of -4, it failed because we didn't know how to take the square root of -4. But now we do, because this negative inside the radical is going to come out as I. And yes, because what that leaves us with is, not square root of 2, square root of 4, and the square root of 4 is 2. And whenever we do take the square root of both sides, we need the plus and minus. I forgot to put that down. But that's telling us that the solution for this are plus or minus 2i. So yes, it still follows, just like the graph said, we don't have real solutions. 2i, -2i are not real numbers, they're imaginary numbers. We do have two solutions, they're just not real. Questions on this here? Okay. Now the graphing calculator will let us check this here. kind of like that there. We can say 2i squared plus 4, which is 0, just like we wanted. I can do the same thing with negative 2i squared plus 4, and it still gives me 0, because that's what we wanted. And that's it. Questions on this here? Be ready for the next one. 2x squared minus 11 equals negative 47. Just like the previous one, we could try graphing it. It's not going to give us something that's going to be nice or helpful. But we can still use the square root method, because the square root method is really the only method we have so far that will solve these, where what it equals is irrational. We're left with radicals, or I. Here, what's our first step? We need to add 11 to both sides, which will tell us that 2x squared is equal to negative 36. Is x squared by itself? No, so we need to do what? Divide both sides by 2. 2x squared divided by 2 is going to be x squared. Negative 36 divided by 2 is negative 18. X squared terms by itself, so now we can take the square root of both sides. On the left-hand side, the square root and the square would cancel, leaving x by itself. Again, I didn't do it on the last one, but whenever we take square root of both sides, we have to put the plus or minus, because x could be the positive or negative case of our negative square root of 18. Now, unlike the last one, square root of negative 18 doesn't simplify as nicely as the square root of negative 4. But the negative inside the radical does come out as I. And what that leaves us with is the square root of 18. We just need to simplify it to finish simplifying that side. Now the 30xs, the yellow calculator, can't take the square root of a negative number. But we know that negative is going to come out as I. So we remove the negative as I and just tell it, hey, take square root of 18, which is 3 square root of 2. So it tells us the square root of 18 is 3 square root of 2. But that also means that the square root of negative 18 is 3i square root of 2. And that's it. Questions on this here so far? We're ready to find the zeros. Questions on this here before we look at the next one? We want to find the zeros of f of x equals 4x squared plus 20. Again, when it's asking us to find the zeros of this function, what it's saying is it wants us to find, or we want to determine, what values of x is going to make 4x squared plus 20 equal 0. Just wanting to know what's going to make this thing equal 0. No middle term, and again, if we graph this, this is not going to cross the x-axis. Funny enough, when I pulled the graphing calculator up earlier, how it had the graph listed, that actually was 4x squared plus 20. It didn't even show up on the graph. But we can use the square root method. And the square root method is our one method that works on these here. When the solutions are imaginary or irrational, we can use it and still get an answer. So the first thing we can do is subtract 20 from both sides. And if we subtract 20 from both sides, it tells us that 4x squared is equal to negative 20. What can we do next? We can divide both sides by 4. If we divide both sides by 4, our 4x squared divided by 4 is x squared. Negative 20 divided by 4 is negative 5. Now we need to square root both sides, because our square root and square will cancel, leaving us with x is equal to plus or minus. Now the square root of negative 5, the negative is going to come out as 9. And what that leaves us with is the square root of 5. Now we need to check and see if the square root of 5 reduces. Well, it doesn't. Because in the 30xs, if you type in the square root of 5, it tells you it's the square root of 5. It gives it right back to you. And all that's saying is that the square root of 5 does not reduce. There's not a perfect square factor for it. So just x is equal to plus or minus I square root of 5. Questions on this here? Now, it'd be nice if every single one worked that way, where I could just take this, get it to a point, take the square root of both sides, and then solve from there, and then we're done. Because up to this point, we've seen, especially with these here, graphing doesn't work and factoring doesn't work. But this one square root method does, because it doesn't have a middle term. We can do that there. Well, if we look at this one here, I can't take or use the square root method because we do have a middle term and I don't have just a single set of parentheses being squared. So we'd have to do this by a different method. Now normally, the way we've done these up to this point is we would get this thing equal to 0 and go from there. We're going to do this a little different. I am going to factor, but I want to factor the x squared minus 16x plus 64 as it is right now. And there's a reason for this, and we'll see it here in a minute. Now, the x squared minus 16x plus 64 does not have a greatest common factor. So we can move on to our 2 sets of parentheses with 3 spaces. Now, since the third term is positive, the signs are the same and match the sign of the middle term, which is negative. So we have negative and negative. Factors of x squared. Well, the only factors are x and x. Factors of the third term, 64. We have 1 and 64. 2 and 32. 3 is not a factor, but 4 and 16. 5 is not a factor. 6 is not a factor. 7 isn't a factor. 8 and 8. Which one do we want to try first? 8 and 8. And if we check this here, x times negative 8 is negative 8x. Negative 8 times x is negative 8x. Negative 8x minus 8x is negative 16x. That's the middle term we wanted. Questions on how we got to this point here? Now, at this point, the zero product property means nothing for this problem. Because zero product property states if we have 2 or more things multiplied together to equal 0, one of them has to be 0. This is not equal to 0. It's equal to 100. There's many, many different ways we can multiply 2 things together and get 100. So that doesn't work. But what is special about these 2 factors is that they are what? The same. We have it being multiplied by itself, which means I could actually rewrite this as x minus 8 squared is equal to 100. So this is kind of nice because x squared minus 16x plus 64 did factor. Not only factored, but we were able to write it as a single set of parentheses being squared. We're able to rewrite a single set of parentheses being squared, which means we can now use the square root method on this. Because again, we need a single thing being squared, a square root. Because if I take the square root of both sides at this point, the left-hand side, the square root and square would cancel. That leaves us with 8x minus 8 is equal to plus or minus the square root of 100, which is 10. And the other nice thing is it doesn't matter what's on the other side where that 100 is. If it's a perfect square, great. If it's a positive number, great. If it's negative, that's fine too. Because again, we have ways to simplify that radical. So this here is giving us a way to do this. But the only way this works is if this quadratic is what we call a perfect square trinomial. It can be rewritten as a single set of parentheses being squared. Yes? This, and what we're about to do with this section, or this part of the chapter, is learn actually how to make it be a perfect square trinomial. And there's actually a way to do it so that it factors this way every single time, thus giving us the first way that we can solve any quadratic that works every time. But we're not quite done with this here. We still need to solve for x, yes? What do we need to do next? Add 8 to both sides. Negative 8 plus 8 is 0. So x is equal to 8 plus or minus 10. Can we add 8 and 10? Question? Okay, I just want to make sure. Because at this point, and part of the reason we do put the 8, or whenever we add or subtract, we want to put in front of the plus or minus, because we do have two different statements here. 8 plus 10. 18, they are like terms, we can add them, yes? If we can add them, if we can subtract them, we need to add and subtract. Because 8 plus 10 is 18. We also that x is equal to 8 minus 10, so x is, so we have two answers. If we can add and subtract them, we need to add and subtract. Now, if the number that's simplified from that radical still had a radical, or has I, or has both a radical and I, has both, that's as far as we can go. Like on the last one. Because if we have, say, 3 square root of 2, I can't add 8 and 3 square root of 2. They're not like terms. They're not combinable. Or if it was 10i, I can't add 8 and 10i. Well, I can. It's just 8 plus 10i. It doesn't make it simpler. It doesn't make it any nicer. We just leave it with the plus and minus. Here we can combine, so we need to combine. Does that make sense? Okay. But now the big linchpin of this is making sure, or figuring out how we can make a perfect square trinomial. Yes? There's a nice formula for doing this. Y'all ready to learn it? I mean, here and there. Because this method is what we call completing the square, because we're going to make a perfect square trinomial. We're going to complete that square. And to do that, first thing we're going to do is find out how to get a value of c that will make it be a perfect square trinomial. And the formula for finding this c is b over 2 squared. C is equal to b over 2 squared. So, To make this a perfect square trinomial, we're going to find that value of c. And a, b, c is all referring back to the general form, our ax squared plus bx plus c. And looking at this equation here, what is the value of a? 1. Since there's not a number written in front of x squared, a is 1. What's our value of b? 14. Well, we don't have the value of c yet. That's what we're trying to find. We're trying to find a c value that will make this a perfect square trinomial, so we can rewrite it as a single set of parentheses being squared. Now our c value, c is equal to b over 2 squared. So we said b is 14. So our c value, the value we're looking for, is 14 over 2 squared. Now, it is possible at this point to type that whole thing in the calculator and let it do it for you. I would wait to type it in. And there's a main reason, and I will point it out here in a second. But the first thing I would want you to do is divide first. 14 divided by 2 is 7. Okay. Now you can plug it in, 7 squared, let it do it. And it is indeed 49. So our perfect square trinomial is x squared plus 14x plus 49. So for this here, for these problems, that's half the answer. The other half is to write the expression as a square of a binomial. All that's saying binomial, so two-term polynomial expression. Really, all it's saying is to factor it. And when we factor this here, we will have a set of parentheses being squared and x. And especially for completing the square, we're just going to have x squared. There's not going to be a number in front of that x squared. Now, it's figuring out what goes in this other spot. Because we're missing a number and a sign, yes? And this is what's nice, or at least I think it's nice. I don't need a crayon. Is it is 7, but it's not only that, the number and sign of what we have inside the parentheses before we square it is what's going to go inside that set of parentheses there. So yes, 7 will go inside here. And since it's positive, it is plus 7. That's why I said it's nice to divide by 2 first before we square it, because since that plus 7, we have it there, we just plug it in. Now on that same coin, if it had been negative 7 before we squared it, it'd be x minus 7 squared. It gives us the number and sign. Whatever the number and sign is, and finding c before we square it here, will be the number and sign that goes in here. And that's it. At this point, we're not solving for anything. We're just trying to set this up. Because this here, being able to set up that perfect square trinomial is what's key for us being able to solve these by completing the square. Questions on this here? We're going to do 3 more solving for C. Are you ready for the next one? Okay. We have these 3 here. We're going to find C. And then factor. I'm going to break my page up like this here, just to make sure it doesn't overflow from one to the next. X squared plus 8x plus c. We need to find the value of c, which is equal to b over 2 squared. Now a for this one here is 1. B is positive 8. C, that's what we're trying to find. Now our c value is equal to b over 2 squared. Well, our value of b in this case is 8. Now the first thing we need to do is divide 8 by 2, and if we divide 8 by 2, we get 4. And 4 squared is 16. So our perfect square trinomial here is x squared plus 8x plus 16. Questions on this here before we factor it? Now the number inside the parentheses before we squared it was positive 4, yes? So the number that goes in here with x is going to be positive 4. And that's it. Are you ready to look at the next one? X squared minus 2x plus c. C is equal to b over 2 squared. Well, our value of b in this one here is what? Negative 2. A is 1, b is negative 2. Now again, I would divide by the negative 2 first before we square it. And negative 2 divided by 2 is negative 1. And negative 1 squared is 1. Telling us that our perfect square trinomial is x squared minus 2x plus 1. Now when we factor our single set of parentheses squared, the number that will go in there with x is our negative 1. The number inside the parentheses before we squared it to find c. Questions on these here? We ready for the last one of this type? All right. Need to find c. C is equal to b over 2 squared. Well, our b value in this case is negative 9. Negative 9 divided by 2. Does that divide nicely? No. Now for these here, it's neither here nor there. We can leave it as a fraction. We can write it as a decimal. We could write it either way. But especially when we start completing the square, it's going to be better to leave it as a fraction than it is to leave it as a decimal. Turn it into a decimal. Because again, as we've seen on the one we just did a minute ago, we're going to have to take square root of both sides. It's better to take square root of a fraction than it is to try to take square root of a decimal. Now, since this doesn't simplify, it's just negative 9/2, we're just going to go on and square it. And if we square negative 9/2, we get 81/4, telling us that we have x squared minus 9x plus 81/4. So x squared minus 9x plus 81/4 is our perfect square trinomial. Now to factor this, we'll have our set of parentheses squared in x, and the number that goes inside there would be negative 9/2. Because negative 9/2 is the number inside the parentheses before we squared it to find c. So it's our number that goes inside our parentheses when we factor. Questions on this here? So we feel comfortable with finding c, yes? All right. So here on the back page there should be two example problems, yes? I want you to go about halfway down that page because you're not going to need the whole page. These are the four main steps for completing the square. So I want you to go and write them down. We'll have them again. I need to add those into the note sheets, but So the first step is a equal to 1. If not, make it so. Our second step, get all the constant terms away from the variables and leave two spaces. Get the variables by themselves and leave spaces to find C, or to plug C in. Our third step is to find the value of C, which is indeed equal to b over 2 squared. We find that and plug it in. And defining our perfect square trinomial really is just factoring the thing. We want to factor it. And then solve from there. I would say that this looks like a lot with these steps, but it's really, once we start using this, there is not a lot in doing this here. I think y'all are starting to know that a lot with the Algebra 2 stuff. For so much of the stuff we're doing, there's a lot to it, not a lot to it all at the same time. All right. Because we're going to do one of those two there. All right. We want to solve this here, x squared minus 10x plus 7 by completing the square. I'm just going to rewrite it. You do not have to rewrite it. So here, completing the square, the first step is a equal to 1. Is the number in front of x squared 1? Yes, because if not, make it so. Well, it's already 1. We don't have to do anything to that. Step 2, get the constant term by itself. We're going to get the number without x squared, all the numbers that don't have a variable on one side, numbers with variables on the other. So x squared and x are on the same side. We just need to get the 7 and move it away from them and leave two spaces. So on the left side, we'll have x squared minus 10x plus blank is equal to negative 7 plus blank. Because the main goal of completing the square is to get that x squared minus 10x plus whatever c is to be a perfect square trinomial, so I can rewrite it as a single set of parentheses being squared. Questions on steps 1 or 2? We're ready for step number 3. Step number 3 is to find the value of c and plug it in. Well, c is equal to b over 2 squared. If we look at this equation here, what is the value of b? Negative 10. And again, just like the last ones we did, we're going to divide it by 2 first. Negative 10 divided by 2 is negative 5. And negative 5 squared is 25. And if y'all are wondering, yes, C will always be positive. C is always going to be a positive number. Because there's no way to square a number and get a negative. That's why we ended up having I, or the issues with I. Questions on steps 1, 2, or 3? Be ready for step number 4. So we need to find the perfect square trinomial. We need to factor this side. Our single set of parentheses squared. We have x. Now the number inside the parentheses before we squared it to find c was negative 5. So our factors for this here is going to be x minus 5 squared. Questions on this so far? We do have to simplify the other side. Negative 7 plus 25 is 18. Now we need to square root. Now we're just going back into the square root method. We're going to square root both sides. On the left-hand side, the square root and the square will cancel, telling me that I have x minus 5 is equal to plus or minus. Now, the square root of 18, that's nice. Well, interestingly enough, it's right there. Square root of 18 is 3 square root of 2. At this point here, we just need to solve for the value of x. And the last thing we need to do is add 5 to both sides, telling us x is equal to 5 plus or minus 3 square roots of 2. Is 5 and 3 square roots of 2, are they like terms? Nope. We can't add them, we can't subtract them and get something simpler. So that's the final answer. What do we think? Is completing the square as daunting as you thought it might be? It's not too bad as long as we keep those 4 steps in order. But that is it. 3 and 5 are like the first two we did, or the first one we did, where we got that set of parentheses squared and went from there. If you do have questions on it, ask. 11 through 18, you're wanting to find the value of c to make that perfect square trinomial and rewrite it as a single set of parentheses being squared.